This is project 5, video number 3, the documentation and finishing touches. I think first thing I want to do is to title the graph. And let's see, we're plotting the x component of the electric field. That's all there is, so it's actually the magnitude of the electric field, but I'm going to call it x component of electric field on x-axis versus x. And let's see how that looks. Control S, run it. X component of electric field. Yeah, it fits. I think that looks alright. I decided I actually do like that line in there, so I'm going to make that as a change in this video. 1,000 points in there, graph EX instead of 1001. So Control S, command window, run it again, and there it is. The thing is, at 0, right at the center, you got the same distribution of positive charge above you as you have below you, so the electric field actually is 0 at that point, so this includes that point in the graph, and then it jumps on either side of that exact x equals 0 position, one way or the other. Alright, I want to try to title the axes. I think it's X label. Oh, that looks good because it's popping up as I type. X, and that's in meters. Put that in square brackets so it doesn't look like it's X as a function of something. It's called M, like X is a function of mass. Control S, run it and see. Yeah, looks like I do remember. Oops, you can't see that. So I do remember the name for that command. That's good. And so this must be Y label. Y, again, it's in meters, square brackets, so it doesn't look like it's Y of mass. It doesn't look like it's a function of M. Control S. X component of electric field on x-axis versus x. Y in meters. It's supposed to be E subscript x. I think I just typed in the wrong thing there. Yeah, it is the y-axis, but it's E sub x. Control S. Try it again. I like the fact that when you use that underscore, it turns it into a subscript automatically. That's kind of cool. Except that's not in meters. How about newtons per coulomb? Control S. E sub x in newtons per coulomb versus x in meters, and I think I'll put an extra space just because I think it'll look better that way between the quantity and the units. So yeah, I like that better. I think we're there on the graph, and then editor, let's see what I would type in here. I think I'm gonna help you out. You have to make sure you use your own words, so yeah, I'm afraid if I say it, if I type it all in, then you might it limits your choice of how to express it, because you have to avoid my words. So I will talk about it though. So clearly state what the function does in a manner that does not require it does, and then you got to include your name. And then I think I'll copy these two lines. Change that to OUT. So this function has no arguments and it returns nothing. That's why I call it dummy. Create. I wanted to talk about what this function does. This function creates a graph of the x component of the electric field due to a line of charge as a function of x for x from minus 0.025 meters to 0.025 meters. The line of charge extends along the y-axis. The line of charge creating this electric field extends along the y-axis from y equals minus 0.025 meters to y equals plus 0.025 meters. And on that line of charge, the linear charge density is 1 times 10 to the minus 6 coulombs per meter times the absolute value of y. So include all that information in your function description. You can probably say it more better than I did. Once you start writing it down, you can edit it to make it just to say it concisely, completely, and clearly. Alright, but that's the idea. Then I'm going to include some attribution. Seem to do say what I did say that you have to provide the attribution in every subroutine, so you really have to include it in every subroutine to get credit for the documentation and finishing touches. Control V. So we got that there. All this other stuff needs to be in there. For you, this is a different one, so percent. Say what the X does. Be complete. In other words, a person is not supposed to have to read the handout in order to figure out what this function does. And the answer is it calculates the electric field due to a line of charge at a point on the x-axis whose coordinates are x, the value of x provided by the user, and 0, x comma 0, where x is a value provided by the user. Now the line of charge we're talking about extends along the y-axis from minus 0.025 meters to 0.025 meters. And on that line of charge, the linear density is given by 1.0 times 10 to the minus 6 coulombs per meter times the absolute value of y. Actually, I've said that twice now, and I'm not really sure. Yeah, it's 1 micro. Ooh, I think I did say that wrong. So in both cases, it's 1 times 10 to the minus 6 coulombs per meter squared times absolute value of y. Make sure you get that right. So, maybe how to make a note of that for I should state that is 1 times 10 to the minus 6 coulombs per meters squared. I think I said times absolute value of y. I think I said something else. And that's the end of my parenthetical statement. I'll put the period over here so it doesn't look like it's part of the equation. Alrighty. So you have to do more than I did there. I'm just telling you what to do as opposed to doing it. And then I got the name. See if anything's complicated here. Now I fill up an array of x values. I evaluate e at that, or find out ex at that, all those values, and then I plot it. So I think that's really pretty clear. So that part about needing to explain unclear statements, then ex is equal to this. I'll say this is the Coulomb constant. Percent. I think that needs a little explanation. Percent Coulomb constant in Newton times meters squared per Coulomb. In this context, line of charge is on y-axis from y equals minus a to y equals a. It tells people what that constant is. This constant is not an input variable or an output variable. And then percent linear charge density is b times absolute value of y. And I gotta say, after you thoroughly explain what this function does, state that it's by you. If you don't have your name in it, you don't get credit for it. And then percent input variable x then you have to clearly what x is, and then percent. I'm going to copy this. OUT Shift S, and then N. No. Alright, output variable is none, right? Oops! Nope, I got that wrong. And then you have to clearly state what eSpecs is. Alright, I think that's looking a little bit better. I think I'm ready to look at the checklist. So, complete algebraic solution, including any relevant diagrams, and I did have one. An outline of the steps, I had that in the pencil and paper part, I'm good. And then 1 point for a reasonable attempt at writing the program, I think I did that. 2.m files, got that. I'm going to make sure I save those. So save that one, and then go over to this one and save that one. Cancel. Wait a second. I've had to have saved that before. Let's make sure it runs. Producing a graph. Looks good to me. Okay, not spitting out any extra stuff to the screen. This up here was when I was playing around with making sure something worked. What was that? EX of A. Yeah, I wanted to make sure it worked with an array, a bunch of values. Alright, back to the checklist. It does consist of 2. I think it works properly. Does what it's supposed to do. Nothing extra printed to the screen. I got nothing extra printed to the screen. No error messages, no warnings, no values of things that are used inside the program, either one of them. Okay. 1 point. For documentation and finishing touches, you actually have to have your name in every file. If it's not there, you don't get the point for documentation. So I think I remember putting it in both. Oops. There it is in one of them. And there it is in the other. Okay. So I got that piece of the checklist. The code must be documented. Comment starting on the first line saying what the function does. I didn't actually do that, but I did put in, so for each function, I did put in each function, where to go, a statement saying that you have to say what the function does. There's one there, and there's the other one. Okay, oops, up to here. And what else? Another set of comments providing a list of the arguments of the function, the input variables, with beside each argument a statement of what the variable is. If there are no input variables, you must say so. And then if it returns anything, so the same thing for the output variables, input and output variables. So let's see what we got here. Input variables, I got that, and there really are none. It has no arguments. Output variables, I called it dummy. I never assigned anything to dummy, so there are none. So that worked out. And then the other one, alright, there's an input variable, it's EX, and to make those stand out a little bit more. So the input variable is X, and you have to say what X is. I haven't done it there, but I've indicated that you have to. And then E sub X, this is where you get to do a little bit of creative writing, say exactly, well, I don't know if you call it creative, but descriptive writing. Say exactly what E sub X is. X component of the electric field at a point on the X-axis. Alright, so I have input and output variables. Next item on the checklist. Not self-explanatory. Yeah, I think I decided that some of the constants that I was using were not self-explanatory. We're clearly evaluating the formula that you used to get E sub X in terms of the other quantities. So I didn't think that needed any clarification. Then over here, I said everything was straightforward. In my opinion, everything is straightforward. You can tell just by looking at it what's going on. So enough about non-self-explanatory code. Alright, for the case of a function that produces one or more graphs, okay, we do produce a graph, so this is relevant here. Each graph must be titled, and each axis must be titled with the units and the name of the quantity. So I did that. If there's more than one plot, we don't have to worry about that. Alright, so just quick look at the graph that it produces. I think it said title of graph, and then each axis labeled with physical quantity and units. And E sub X really does have units in newtons per coulomb, and X has units in meters. So I think we're good on that. Let's make sure. Title, each axis title with units and name of quantity. That's all that applies, because we don't have more than one plot on the same graph. Then you must provide attribution. You don't get credit for the documentation if you don't give attribution. Make sure it's not identical to mine. I don't think it will be. I don't think anybody would write the same thing I did. Let's get rid of that. Then go there. And got attribution in that one. Say what you used to help create this program. Actually didn't have any of my own this time. And say what you used to create this program. In other words, I wrote it all on my own. So I've gone through the checklist. I'm confident at this point that I've got everything. Now it's just a matter of submitting the two .m files via Sakai. Sakai should be open for you to submit it many times. I'm going to try to make sure that. So assignments, we got project 5. Doesn't say how many times you can submit it, so you got an unlimited number of submissions up until 4/8 at approximately noon. I go a little past that just in case the clock's off. But 4/8 is the Saturday. So yeah, you got to submit 2.m files. So you can submit them, you can look at them after you submit them, you can submit a new version and delete the old. Just make sure I've only got 2 files. Each one is the latest version. It's not a bad idea. I found out it helped one person get some credit for it, where they submitted it before they had it completely done. I think maybe before they, before they had it completely done, and then they forgot to submit the latest version when the due date came around. I guess they were busy on that Saturday and they never submitted it, but they still got some credit for at least a reasonable attempt at writing the program, because they had essentially saved it to Sakai while they were working on it. So you can do that as long as you got a reasonable attempt. You can get some credit for it. Alright, so this thing's saying some revise, and I better hit the cancel button here. Cancel, and then should be ready to go for you. Alright, that does it for Project 5 Video 3, the documentation and finishing touches.